Okay, geometry students, welcome to class today. In this video, we will be looking at two theorems and one corollary. Okay, I will explain later what a corollary is. The theorems and corollary are dealing with angles of triangles. Okay, the theorems and corollary are dealing with angles of triangles. So, your heading for today is angles of triangles. Okay, angles of triangles, lesson 4.2. Lesson 4.2, and please include today's date. All right, so angles of triangles, please copy that in your notes, and the lesson today is 4.2. Be sure and include today's date. Okay, all right, let's jump into this and let's see how we do today. Here we go. Before we go any further today, we need to pause and go over what, listen to me, interior angles, exterior angles, and remote interior angles of triangles are. Okay, so let's do that now. Students, listen to me. Please listen to me carefully. Everyone should be taking notes. Listen to me. I am not going to give you definitions of these and make you memorize them or do fill in the blanks on a test or a quiz. I'm not going to do that, but you still have to know what they are and be able to locate them on triangles. Okay, so please take some really good notes, and here we go. First of all, copy this triangle in your notes if you would, please. Copy this down, okay? There we go. Copy that triangle in your notes. And let's go ahead and call this angle 1. Let's call this angle 2. And let's call this angle 3. Would you please write that in your notes, students? Copy that down, okay? Now, take some really good notes. I'm going to slide this over a little bit. And let's take some really good notes. First of all, write this down, please. Angles 1, 2, and 3 are called interior angles of a triangle. Isn't that easy? I mean, interior means on the inside, and those three angles are on the inside, correct? That's really simple, guys. Okay, so angles 1, 2, and 3 are called interior angles of a triangle. That is really simple. Please make note of that, okay? Now, here's where a lot of students get in trouble. Don't write anything down, just watch, okay? Do not do what I'm about ready to do, just watch, okay? A lot of students like to extend this line here and then extend this line here, and they call this angle right here an exterior angle, and that is incorrect. Okay, the only way, okay students, I'm back, sorry about that, I had to take care of a little situation. Okay, here's the deal. Now, a lot of students like to extend a line here, and call this exterior angle. That's wrong, so please take some really good notes. Okay, an exterior angle of a triangle is formed when you extend one side. Now look, I don't care which side you extend. If this bottom side here is extended like this, then this is called an exterior angle. Got it? Don't write anything down yet. Just watch, okay? Just watch this. Or I could extend this side here like that, and here's my exterior angle. In other words, this is a vertex, this is a vertex, and this is a vertex. At every vertex, we have two possible exterior angles. Two. Let me show you. At this vertex over here, we could extend one side, and there's an exterior angle. Or we could extend this side here, and there's my exterior angle. Or I could extend this side here, there's my exterior angle. Or I could extend this side here, and there's my exterior angle. Okay, so anytime you take a side from a triangle and extend that side, you have an exterior angle. So in your notes, if you would please, go ahead and extend this side here and put a little mark here, and then we're going to call this angle 4. So off to the side, put angle 4 is exterior angle. Angle 4 is an exterior angle. Okay? Everybody good with that? Now let's move on. Listen to me carefully. We've covered what interior angles are, the three angles inside of a triangle. We've covered what exterior angles are. Exterior angles, put a check mark here. Exterior angles are formed when you take one side of a triangle and extend it, okay? Now, how about remote interior angles? Well, here's the deal. Please listen carefully. You can never have remote interior angles unless you have an exterior angle. So, if this exterior angle is not here, like that, then you have no remote interior angles. However, if you have an exterior angle like this, then these two angles here would be the remote interior angles. See this angle right here, 3, next to the exterior angle? That is not a remote interior angle. It's the two angles that are not beside the exterior angle. Okay, so watch this carefully. If I were to extend this side here, watch, and call this my exterior angle, we'll call it angle 5, then my two remote interior angles would be this angle here and this angle here. Why would it not be angle 2? Because angle 2 is the angle that's right beside my exterior angle. The angle that's right beside your exterior angle is never your remote interior angle. Are you guys getting this? I hope so, okay? Take whatever notes you need to understand this. Look, if I extended this side here, so I had an exterior angle here, we'll call this angle 6. If angle 6 is my exterior angle, the two remote interior angles would be this angle here and this angle here. It would not be this angle, because this angle here is the angle right beside my exterior angle. Okay, so please understand that. I'm not really sure how to write that. I guess we'll do it like this. Let's do it like this. In your notes, I would extend this side here. Go ahead and put your 4. And I would say angles 1 and 2 are your remote interior angles. Now we're going to use this information today on the very last theorem we look at, so please don't forget this. Interior angles, angles on the inside. Exterior angle, the angle on the outside. Remote interior angles are the two angles that are not beside your exterior angle. Okay? Okay, moving on. Here we go. Now, let me quickly explain what a corollary is. You do not need to memorize this. You do not need to know this for upcoming quizzes and tests. I just want to quickly explain what a corollary is, okay? A corollary is a statement that relates to a theorem and can be proven easily. In other words, you will usually be given a theorem, okay? And then sometimes the theorem will have a corollary that goes along with it. That's all that it is. It's just another truth or mathematical principle that we're going to learn and apply to math problems. That's it, okay? Nothing more, nothing less. Okay, so let's continue on. You don't need to know that. I'm just explaining what it is so you'll know when you see it what it is. All right? Okay, without any more hesitation, let's go ahead and jump into today's notes. Here we go. Here's our first theorem of the day. Copy this down, please. I will pause while you copy this down. Theorem 4.1. Everybody write this down, please. Everyone should be writing this down. The sum of the measures of the interior angles of a triangle is 180. The sum of the measures of the interior angles of a triangle is 180. Okay? The sum of the measures of the interior angles of a triangle is 180. Okay? So here we go. I'd like you to copy this in your notes. I'll give you a couple more seconds. The sum of the measures of the interior angles of a triangle is 180. Now, after you've copied that down, I want you to draw this triangle in your notes, please. Okay? And then put a 1, and then a 2, and then a 3. Okay, that's what I want you to put. Off to the side over here, I want you to write if angles 1, 2, and 3 are interior angles of a triangle. Write that down, please. If angles 1, 2, and 3 are interior angles of a triangle, which they are, then angle 1 plus angle 2 plus the measure of angle 3 equals 180 degrees. There we go. Okay? So if angles 1, 2, and 3 are interior angles of a triangle, then those three angles, when you add them up, will always equal 180. Now that's really a simple concept, students. All that we're saying is this: anytime you have a triangle, if you add up the three inside angles, the three interior angles, they will always equal 180. Okay? I'll pause a second while you finish this. We're going to move on. Anytime that I go too fast during a video, students, Just let Mr. Hamill or the supervising teacher know, and they'll pause the video, okay? Okay, so let's continue on. Here we go. Okay, this was a pretty easy concept, so I'm only going to look at one example, and then we're going to move on, okay? Please copy this example in your notes. Please copy this down. Draw this triangle. I want you to write angle 43 degrees here, and I want you to write 85 degrees here, okay? I'll give you just a second to do that. Copy that down, please. Okay, we are going to find the missing angle in the triangle. This angle right here, I'll put a question mark, okay? So we know all three angles have to add up to 180. So to me, it makes sense to take 43 and 85. Take some good notes on this, please. Add those together, and you get 128. So these two angles here added together give you 128. So then subtract 128 from 180, all right? And you will get 52 degrees. So we now know this angle right here has to be 52 degrees, because 52 plus 85 plus 43 equals 180. Pretty simple, guys, okay? Really not too bad. All right, let's continue on. So these three angles, when you add them together, will always equal 180, okay? Now let's continue on. Let's look at the corollary that goes with this theorem, okay? So get ready to write this down. Here's our first theorem we looked at, Theorem 4.1. Now we're going to look at a corollary that goes with that theorem, okay? So here it is. Copy this down. Corollary to the triangle sum theorem. And by the way, this theorem here is called the triangle sum theorem. You don't need to know that. I'm not going to test you on that. However, I'm just saying this theorem up here is sometimes called the triangle sum theorem. So now we're going to look at the corollary to the triangle sum theorem. You are responsible for theorems, as you guys know. And you're also responsible for corollaries, so you will need to know this, okay, for tests and quizzes. Okay, corollary to the triangle sum theorem. Corollary to the triangle sum theorem. The acute angles of a right triangle are complementary. The acute angles of a right triangle are complementary. Okay, take a second and copy that down. The acute angles of a right triangle are complementary. The acute angles of a right triangle are complementary. Okay, here we go. Copy this down. Please take some really good notes on this. Go ahead and draw a right triangle, please. Go ahead and draw a right triangle. And we're going to call these angles 1, 2, and 3. Got it? Now this makes total sense, students. Think about this. Angle 2, by the way, is what measurement? 90. So doesn't it make sense that angles 1 plus 3 also have to equal 90? Because 90 plus 90 is 180. And we already know this angle here is 90. So these two angles here added together have to be 90 also, because all three angles have to add up to what? We just learned this. 180. Okay, so here we go. Take some notes on this, okay? Okay, off to the side, write this down. If how should we state this? Let's see. Let's go ahead and call this triangle A, B, C. Copy that down. So if triangle A, B, C is a what? A right triangle. And angle 2 is 90 degrees. So if my triangle is a right triangle and angle 2 is a right angle, then angles 1 and 3 are what? Complementary. In other words, they have to add up to 90. Okay? So again, here's your right triangle, here's your right angle. The other two angles are your two acute angles. Those two acute angles will always add up to 90 when you have a right triangle, okay? I'll pause a second. Remember, if I go too fast, just have the video paused, okay? It's no big deal. I'm going to continue on. Here we go. Now, let me throw a quick problem at you, and then we're going to mix this theorem and the corollary together and look at 3 examples, okay? This problem's pretty tough, so here we go. Okay, copy this in your notes, please. I want you to draw a right triangle like this. A big right triangle like this with your right angle up here. Okay, go ahead and do that, please. Then when you're done, I want you to draw a line straight down like this so that you have a right angle here. Okay, now I'm going to pause while you do all this, and then put an A here, a B here, a C here, a D here, and then 40 degrees goes for this little angle right up here. 40 degrees. Okay, go ahead and do that, please. Okay, here we go. Now, students, my advice to you, whenever you have a triangle within a triangle, I think it's really, really smart to split the two triangles up, and I hope you'll take my advice on that, okay? So I'm going to write a little right triangle over here like this, and I'm going to label that A, B, D. A, B, D, okay? And I'm going to put a right angle here, like I had right over here. I'm going to put 40 degrees right here, okay? Then I'm going to write the big right triangle like this. I'm going to slide this out of the way a little bit if I can, hopefully. That's not going to work, is it? Well, that's okay. Let's just go ahead and do this. We'll put the triangle up here. So we'll put the big right triangle up here. Okay? And I'm going to label this triangle A, B, C. And see, students, it's really a lot more helpful when you split the two triangles up like this, okay? There. Now, let's see what they want us to do, okay? It says, right here, find the measure of angle DAB. Well, here's angle DAB. Here's D over to A up to B. So this angle right here, they want us to find that angle, or in other words, this angle right here. Now, we just learned a corollary that said this. Come on, guys. We just learned a corollary that says in a right triangle, the two angles that are not right angles are what? What are they? Right here. Complementary. So if this angle B is 40, then angle A right here, or a DAB, has to be what? 50. Has to be 50 because 40 plus 50 is 90. And of course, this is 90 over here. So 40 plus 50 plus 90 is 180. So this angle right here has to be 50. So now that I know that, I know this is angle 50. What can I put right here? 50. So what can I put right up here then? The big triangle. 50. And now look how easy this is, guys. Look. This is a right triangle. This angle here and this angle here are not my right angles, so they have to add up to 90. So this angle right here is 40 degrees. And that's what I'm looking for. Find the measure of angle BCD. Well, here's B, down to C, and over to D. I'm looking for this angle right here, which is this angle right here, which is 40 degrees, okay? That's a pretty tough problem. I hope you guys are able to stay with me. And again, I'm going to move on, but if the video needs to be paused, just have the teacher do that. It's not a problem, okay? Let's continue on. Now, I want us to look at 3 problems, okay? You're on your own. I'm going to go ahead. I want you guys to pause the video. So pause the video. Everybody copy this down. Maybe the teacher can roam the room, make sure everybody's working on this. I want you guys to find angle, I'm not sure why I said BAC. Let's just call this angle B. How's that? Let's just change that. Okay? Let's find the measure of angle B. So find the measure of angle B. Okay, so go ahead and pause the video. Everybody work on this, and then unpause it when everybody's done. Okay, students, hopefully you did okay. And this is really not a difficult problem. We studied a theorem today that says that all 3 angles inside of a triangle add up to 180. So 65 plus 50 is 115. And then we'll take 180 and subtract 115. And we're left with 65 degrees. Okay, so there we go. Pretty simple. This angle here has to be 65 because 65 plus 50 is 180. Okay? Okay, next problem. I want you guys to go ahead and work on this. Again, if the teacher could roam the room, make sure everybody's doing this. Go ahead and solve this on your own. Pause the video at this time. And when everybody's done, then go ahead and unpause the video. Okay, hopefully everybody did okay on this. Let's see how you guys did. All three angles, 1, 2, 3, have to add up to 180. So let's take 45 plus 60. We get 105. Subtract that from 180, and you get 75 degrees. Okay, so this angle right here is 75 degrees because 75 plus 45 plus 60 would be 180. Okay, I think I did it in my head. I hope that's right. Okay, moving on to our last problem. This is going to be a much more difficult problem. It'll be like the last problem we did over here, like this, where we have a triangle inside of a triangle. Okay, I want to encourage you guys to write the triangle by itself. I would copy two triangles off to the side. I would copy this little right triangle off to the side. Then I would copy the big right triangle. Okay, and I would see how you guys do. So I want you to find the measure of angle C, this measure up here. Go ahead and pause the video at this time. And then when everybody's finished, go ahead and unpause the video. Okay, work hard on this and see how you do. If you can't figure it out, don't get discouraged. Just wait for me when we unpause the video, and I'll show you how to do this. Okay, students, as I mentioned to you before, my suggestion would be to draw a little triangle like this. We'll call this A, D, E. Even though it looks like a P, it's not. It's a D. Right angle here and 50 degrees here. Okay. Then we'll draw a bigger right triangle like this. And we'll call this triangle A all the way up to C down to B. Put a right angle here. This is the angle we're looking for. Now, in this triangle right here, it's going to be really hard to find angle C because we don't know what this angle here is to help us find angle C. All that we know is this is 90. However, if you go to your smaller triangle, notice we have a little angle here. Okay, that's 90. So if we have a right triangle, then we know our two non-right angles, our acute angles, have to add up to 90. Remember that corollary we learned? The two acute angles in a right triangle are complementary. So if this is 50, then this has to be 40. Now I know that's not what we're solving for, but if that's 40, I can come over here and put what over here? 40. So if that's 40, then this angle up here obviously has to be 50 because 50 plus 40 is 90. So the answer is 50. Okay? I hope that made sense. Okay, if not, pause the video, ask questions, or back it up. Okay, but that's really how you would solve that problem. Okay, just using the corollary, the two acute angles of a right triangle are complementary. Okay, moving on. Now let's finish up with our last theorem. Remember, we talked earlier about interior and exterior angles of triangles. Remember, we're going to apply that knowledge now. So here we go. Please copy this theorem in your notes. I'll pause a second while you copy this down. Theorem 4.2. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Okay? Give you a couple more seconds to copy this down. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Okay? Alright, let's go ahead and copy this in our notes. Copy this down, please. I want you to put a triangle right here if you would. And then extend this line right here. And then let's call this angle 1, angle 2, angle 3, and angle 4. Okay? Now, listen to what we have here. Okay, copy this down, please. If angle 4 is an exterior angle of a what? Triangle, which it is, then the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. That's really cool. So here's your exterior angle. Because 3 is right next to angle 4, we know that 3 is not one of your remote interior angles. These two angles here are your remote interior angles. And what does this theorem say? The measure of an exterior angle is always equal to the sum of your what? Two remote interior angles. So these two angles here, when you add them together, will always equal this angle out here. Pretty cool, okay? So please take some good notes on this. I'll pause a couple more seconds, and if you need more time, just have someone pause the video, okay? Okay, let's continue on. Here we go. Now let's apply this to a couple of quick problems, and then we're finished for the day, so not too bad, okay? Here we go. Copy this in your notes, and I want you to find the measure of angle 1. Okay, copy this in your notes, and I want you to find the measure of angle 1. Now we're going to do this together. I'll give you just a second to write this down, and then you can work ahead, or you can work with me, whatever you want to do, okay? Copy this in your notes. Triangle BAC, exterior angle of 1, and then we have these two angles over here, okay? Alright, here we go. Now understand, angle 1, like I just said, is what? An exterior angle, okay? Well, if this is your exterior angle, then this angle here is not one of your remote interior angles. These two angles here are your remote interior angles. And what did we just learn? An exterior angle is always equal to the sum of these two angles right here. So the measure of angle 1 equals 72 plus 58. There we go. So the measure of angle 1 equals 130 degrees. Okay? 72 plus 58. There we go. Alright. Now, let's take a look at one more problem. You're welcome to work ahead, or you can stay with me. Okay? Here it is. Please copy this down. A little different, so be careful on this one. Okay, copy this down. Copy your triangle, then extend one side like this, and then put 113 degrees here. Then we have these two angles over here. Okay? Alright, here we go. I want you to find the measure of angle 4. Now remember, 113 degrees is an exterior angle, okay? Now if that's an exterior angle, these are your two remote interior angles. Remember, if we take 55 degrees plus the other angle, it should equal my exterior angle, which is 113 degrees. So all that I have to do is take 113 degrees and subtract 55 from it, okay? And then I'll know what the measure of angle 4 is. The measure of angle 4 is 58 degrees, right? Because 55 plus 58 is 113. So whatever answer you put in for angle 4, you could check it. Okay, you could check your answer. I'm saying it's 58 degrees. Let's check it and see. Take these two angles and do what to them? Add them together, and you should get what? 113, and you do. Okay, now I'm going to really be brief on this. I want to show you one more quick thing. Do not take notes on this, okay? Do not. I just want to show you real quick. You might be wondering, Mr. Aaron, how do we know that's true? Let me show you real quick something, okay? Watch. 1, 2, 3, 4. Now, would you please watch this carefully, students? Watch. If I take angle 1 plus 2 plus 3, those three interior angles, what do they equal? 180. If I take angles 3 plus 4, they're a linear pair. Straight line with a line coming off of it. So if I add 3 plus 4, what do I get? 180, right? So look, here's angle 3, here's angle 4. Got it? So look, 1 plus 2 has to be the same thing as 4. Has to be. Because if 1 plus 2 plus 3 is 180, and 3 plus 4 is 180, take away angle 3, take away angle 3, and you're left with 1 plus 2, has to be the same thing as angle 4. Now, some of you understood what I just said. Some of you were like, whew, that's right over my head. That's fine, okay? I'm just trying to show you real quick where we get that from. And then one more quick thought, and I'm done. Mr. Earhart, how do you know these three angles here add up to 180? Well, I'm glad you asked. Thanks for asking, okay? If I were to extend this line like this, I'm done in 20 seconds, guys, okay? If I were to put a line here that runs parallel to that line, remember, what do we know about three angles here coming off of, we have three angles here, angle here, angle here, angle here, okay? So let's call those two angles 4 and 5. What do we know about angles 3, 4, and 5? Well, they all come off of straight lines. We know 3 plus 4 plus 5 has to equal what? 180. Now watch this. Remember parallel lines cut by a transversal like this? Well, this angle here and this angle here alternate interior, so for angle 4 I could put angle 2. I'm probably going way too fast. You don't need to know all this. I'm just trying to show you real quick. And look at this. I have two parallel lines cut by a transversal here. Angles 1 and 5 are alternate interior. They're congruent. So for angle 5, I could put 1. And there it is. Angle 3 plus 2 plus 1 equals 180. Okay? All right. You don't have to know that. I just want to show you real quick where we get that theorem from. Okay? Hope this video has been a help to you guys. Please work well on your homework. If you have any questions, don't hesitate to call. Well, I said work on your homework. If it's a Wednesday, obviously you don't have homework, but if you have any questions, don't hesitate to call or email, okay?